Once again, this is Klaus Darilion from nic.at. I'm working as a sysadmin for nic.at, and I'm working also for our Acute Zero DNS product. And for those of you who have been here yesterday, I was talking about migrating from PowerDNS to KNOT using catalog zones. And one of the problems we had were the synchronization of the zones between a PowerDNS nameserver and a KNOT nameserver. And this lightning talk here is somehow, I want to highlight the problem in a more generic way. And I'm looking for solutions or discussion on if there is a generic solution to my problem. So that's the motivation of this talk. As probably everybody knows, how does the DNS zone replication works? But in the DNS protocol, it's XFR or IXFR. So we have a primary nameserver and a secondary nameserver, and the secondary nameserver fetches the zone from the primary nameserver using zone transfer. So that's true. The question is, when is a zone transferred? There are two two options that trigger a zone transfer. The first one is when the refresh option detects a stale serial. So the secondary performs a SOA query to the primary, check the serial, and when the serial is higher, then it performs a zone transfer. The second option is a notify. Such a notify can also trigger the refresh operation or like a partly refresh operation, and then the secondary nameserver will transfer, will also make a refresh check, and if the serial is higher, perform a zone transfer. So what will happen when, for example, such a notify fails? So, of course, the secondary does not know that the notify was not received. And the primary usually don't care. Maybe there's some entry in the log who says notify failed, but that's usually all the primary does. It does not care about the failed notify, and probably the primary thinks, yeah, the secondary should detect the higher serial during the next refresh check, so I don't have to care about it. So, but what if the refresh check actually works, but the zone transfer itself fails? As before, the primary don't care at all, and most of the secondaries, I'm aware, they just do nothing. They just say, okay, we have a refresh check like in 5 minutes or in 1 hour, and maybe then we also detect the stale serial. We perform another zone transfer, and maybe this time it works. If I ask the question, is the secondary nameserver in sync with the primary nameserver? Out of the box, nobody can answer the question, because the primary does not know the state of the secondary, and the secondary does not know the state of the primary. The secondary only knows the state of the primary when it performs a refresh check. But once the refresh check is finished, it doesn't know the state anymore. So it can happen that for whatever reason, like 1 second after the refresh check, the serial gets incremented for whatever the notify does not arrive. And nobody knows if they are in sync. So what we usually do, probably also you, some kind of out of protocol monitoring is required. So checking the serial on the primary and then the secondary and compare it. This can be done either by performing a SOA DNS query against the nameserver and analyzing the response, or get the serial by some other means. For example, the NSD control utility or the KNOT control utility can dump the state of a zone, which also includes the serial. So how often this should be done? Maybe once per minute or once per second. What we usually do is once per minute. But of course, this probably depends on SLAs. If you have customers, you give SLAs to the customer, for example, for the zone propagation delay. So if you have to have SLAs, you have to detect if the SLAs are broken or before the SLAs are broken. So, but a simple calculation is, if I have one zone and I check every minute, my monitoring must perform 2 queries per minute. That's rather easy, rather simple. And that's what we, for example, do for our TLD DNS products, because there we don't have so many zones. But what if I have a secondary which hosts 1 million secondary zones? So then actually we have, from the DNS protocol, we have not one replication, we have 1 million replications, because every zone is more or less independent from all the other zones. That means I have, with 1 million zones, I have 1 million replications, 1 million independent refresh checks. And actually I have 1 million zones or replication to monitor. So I have to know if they are all in sync or not. So if I do the monitoring by DNS, as said before, 1 zone, 1 minute, that's doable. But if I have 1 million zones, I query every minute, and I have 50 secondaries globally around the world, then my monitoring has to do 833,000 queries per second. Probably some guys would say, hey, use Knot, that's not a problem. We can do that. But the monitoring cannot do it. And also the question is if it's really useful to do it with monitoring, with DNS queries. And what if I have 10 million zones? What if I have like 50 million zones? Where does it stop? And it's not only checking the serials, because if you check 1 million zones, it does not take 1 second. It will take some time. And of course, during that time where we do the monitoring, the serials itself can be changed, because the zones are in the flux, so they change. So it may happen that, like, the monitoring detects that a zone is stale on the secondary, but meanwhile the secondary has already caught up, but the monitoring has not noticed it yet. So there has to be some kind of stateful logic, like retrying zones which are not in sync to check if meanwhile the secondary has caught up or not. And only if, like, after 3 times monitoring, it is still lagging behind, then doing some alerting. So in all this, monitoring is CPU consuming and complex. And in my opinion,
you have 5 minutes until Q&A.
Thanks. So, in my opinion, it does not scale anymore. So, and meanwhile, I have detected that the title of this talk is a little bit misleading, because it's called XFR doesn't scale. So, to be honest, the zone transfer itself, doing with XFR as before, is okay. That's doable, because we don't have like 1 million zone transfers per second. But the refresh checks behind, and the notifications behind, and the monitoring if the secondaries and the primaries are in sync, this is my opinion where standard measure tools are not useful anymore. So, as I have the problem, I have already thought about solutions to this problem. I once had the idea of encoding the serial of a zone in catalog zones, so that attached to each member zone, we also published the serial in the catalog zone, and we had this in the draft, but we removed it because there were some discussions, and to speed up the finalizing of the RFC, we decided to remove it and maybe make another RFC later. And there is some, because if I do that, if I add the serial to the catalog zone, then the catalog consumer automatically can read what is the serial on the master, and it can compare it locally. So there is no need for notifies, and there is no need for like a freshness check. But of course, it would the primary, the secondary would need to implement some logic to check if it's if the serials are in sync, and if they're not in sync, trying a zone transfer. And if the zone transfer fails, somewhere keep in mind or store the state that it failed and retry it like 1 minute later or a few seconds later. And of course, this is also complex logic, and maybe doing. And the thing is, we also had a discussion with one developer, and he said catalog processing is time consuming. So but in serials change very often. So if you have if you encode the serial property in the catalog zone, then you probably have like updates on the serial zone every second. So that may be another drawback. There was also another idea presented by Leo at FOSDEM. I have referenced it here. It is somehow similar, but his idea was not using serial, but the zone MD of a zone. So you could also not see if it changed, but also have like a hash to see if the transfer was successful. Yesterday in the Mattermost chat, there was an idea from Peter, like having just a meta zone for serials and maybe other stuff similar to the catalog zone. Those are the ideas I catched up from the community. Of course, there are also alternatives which are not DNS based. For example, Power DNS with SQL backend, because if you do the data replication in the database, you have usually one single serial stream replication, and monitoring that is rather easy. I just monitoring the replication lag and I automatically know the lag of all the zones at that location. There's also Power DNS with LMDP backend and the Lightning Stream LMDP replication tool. I have not taken a look at that, but that would also probably solve it, because it's also somehow a serial single replication, which should be easier to monitor than like 1 million replications. And probably big providers like Cloudflare, Google, or Amazon, I guess they have proprietary solutions which are not DNS based. So probably they use out some kind of SQL database or whatever database and using some kind of replication, which is self-written, because otherwise, I guess they have also so many domains, and how should they monitor those? So my conclusion is like provisioning and like doing the zone transfer for more than 1 million domains, that's the easy part. But doing the monitoring, if all the zones are in sync, are more complicated than hosting the 1 million domains. And it would be much simpler if we have not checked every domain, each of the 100 million domains, if it's in sync, but if there would be like some aggregated state available in the secondary or the primary, where we can easily compare the synchronicity of the secondary. So, and now I would be, if you have any comments or if you have any solutions, or do you think we don't have to solve it because we just don't monitor it and it works, I would be happy to hear your feedback. Thank you.
So thanks a lot for that. I think when DNS was envisioned, we didn't think that we could have millions or even billions of zones and records. So I think the tools that were designed at that time are just not up to the task. And it shows that pretty much everybody that does DNS at scale, that's including us, Akamai, has come to other solutions. And even, I mean, the software out there like Power DNS or others are using kind of sort of database-driven solutions. So I think if we want to solve that problem generally, we either have to extend what we do into a kind of more coherent database story, or, I mean, let it do by some other existing mechanisms.
Thanks for the feedback. It would be interesting if there's anybody interested in like implementing or extending the DNS protocol or doing whatever on a standard-based way. So maybe that it works also between different name server vendors and not within proprietary solutions or only within Power DNS. And of course, we can do this discussion on the Mattermost channel if somebody would be happy to provide feedback or discuss this topic.
Hi, Klaus. Jim Reed, freelance consultant. It's an interesting problem that you've got here, and all I can say is I'm glad it's you that has to deal with it and not me. I don't think we could possibly come up with like a standardized solution for this, because I think it would be too generic, because trying to figure out how to do this in a generalized way is going to run into the problems of different sorts of requirements and operational needs and service level agreements, and these will differ between provider and their clients and between the providers themselves. So I'm not sure that a standardized solution could ever be achieved just because there'd be such a diversity of competing requirements and so on. It's certainly worth having a discussion about it. And I'm really not sure if we could ever come up with a solution that could then be taken to the IETF for standardization. Maybe you could come up with some best common practices, some guidelines that could be circulated through OARC. I don't think standardization is really going to be an achievable thing in this area. And I think we also need to remember too that the DNS is loosely coupled. The fact that the masters and slaves or primaries and secondaries are sometimes out of sync with each other is a fundamental feature of the design of the protocol. And yes, we would like to make sure these things are kept fairly close in sync. But if there's a delay of a few minutes and so on to keep these things synchronized, in my opinion, most of the time it's no big deal. Of course, there are occasions where it is really important to get these synchronized much more quickly than that. And there are other methods, as you've already pointed out, how those could be dealt with. But for the general case, for a random member of the public, such as myself, I don't really care if one of the servers that's providing authoritative service for my domains takes a little bit longer than usual to synchronize. A couple of hours is neither here nor there from my point of view. But then maybe I'm at a different part of the food chain from someone that's operating DNS for a bank or something like that.
Thanks for her feedback. Yes, the thing is, we have implemented such a monitoring, and it turns out that most of the time, actually always, it works. So we don't, of course, it's at the moment in our setup, it's only locally, and the name servers are always in sync. But without monitoring, I wouldn't know that. And somehow I have to know that if I have SLAs for my customers.
Hello, Martin from Barry Media. I would question if there is an actual demand. I mean, I know the ARCAD 0 setup where registrars create a zone and then you're passively waiting for updates from hidden primaries, and at some point you want to publish them on all the nodes in your Anycast cloud. But I would assume that the majority knows when an update happens, and you just push for an update in kind of API. Like if a customer would enter a new record in our customer portal, or maybe more advanced user would do that via an API, then we update the record in PowerDNS, and then we push an update, or like we immediately fetch the zone in our Anycast provider because we're quite impatient, or if we have Let's Encrypt ACME protocol, we don't want to wait for maybe minutes or hours until some update happens. We want to finish with the transaction as soon as possible. And I just wonder if there maybe could be an update in the way your customers handle zones. Maybe they could be asked to push actively as well, like ask for an update immediately. Because in our setup, we know when an update happens, and all the requests or like the monitoring by the fetcher or like this secondary kind of in setup in traditional language used to bombard our name servers without any use, because there won't be any update without us calling their API. So we're just negotiating them with them to disable this kind of permanent XFR requests without demand. And to summarize, I know your setup, but I wonder if there's any huge demand and the whole industry, maybe on enterprises who just want to update a certain record and otherwise don't touch the zone for a long time. Okay, thanks for the feedback. So basically from the customer to us, this is not a problem, because of course we are at the API, we receive the data, but finally somehow all the data via APIs or whatever it is inserted has to end up in the name server. And if you have a transfer between different name server vendors, there's only one protocol which is supported at the moment, and this is the standard DNS zone transfer. And this, as Jim before said, it's rather loosely coupled, and there is no feedback if like an update really arrived on the other side. And so this is where we have the problem. We just want to, actually we don't have a problem. It works, but I want to be sure that it works, and somehow I have to monitor. And at the moment, the monitoring is more CPU consuming as all the DNS service itself.